All right, lesson 7.4, we're factoring trinomials when a does not equal 1. Now, first off, somewhere on your notes, I want you to write in big letters, always check for greatest common factor first. So, like we did in our last lessons, if you can factor out a greatest common factor, always do that first. And we'll have a couple examples where I show you what that looks like. Now, going on from here, anytime we're factoring a trinomial, we'll have them as, again, like before we were talking about quadratic trinomials. So they're in the form ax squared plus bx plus c. Now before, all of our quadratic trinomials, the a was 1. So it was just 1 out front here, or just x squared alone. Now we're going to look what happens when our a is not 1. So when we have something in front of that x squared. So as an example, 6x squared plus 7x plus 2. This is an example of one of them we will be able to factor. 6 is the a value, 7 is the b value, 2 is the c value. Okay, so in the end, I'm going to show you, well, right now I'm going to show you what it's going to look like, or what we're going to be doing. But I won't explain it as much as in our next example. So I'll show you what's happening first and then explain it a little more through our next examples. So in words, what's happening is when we factor our trinomials that are of the form ax squared plus bx plus c, we're finding two numbers, m and p, that will sum to b. So they add up to this middle number. Like in this case, they would add up to 7, and a product of ac. So they multiply to these two numbers, 6 times 2, and they would add up to 7. So then we would change it into ax squared plus mx plus px plus c, then factor by grouping. So that might sound kind of complex right now. I'm going to show you first off what's happening. When we start off with a trinomial like this 5x squared minus 13x plus 6, we're splitting the x term into two pieces. So it would look like this. 5x squared minus 10x minus 3x plus 6. Now when we do that, we can factor by grouping. We have a group here, and we have a group here. Okay, so the first thing we had to do is split it into two pieces. Now, the question might come up, how do we know which two pieces to split it into? Why did we split it into minus 10 and minus 3? And I'll explain why we split it into those ones in our next examples. But that's basically what we're doing. We're splitting it into two pieces. Then we're grouping them so they're kind of ready for factoring. We have this green group and this red group. The green group we factored out as 5x, is what we took out of both of those, times this binomial x minus 2. Underline that in blue. We have an x minus 2, so 5x times x became 5x squared. 5x times minus 2 became minus 10x. And here we have that same binomial, x minus 2 is over here, x minus 2. So what did we factor out of this to make it x minus 2? We had to take out a negative 3. Because then negative 3 times x is minus 3x. Negative 3 times minus 2 becomes positive 6. Okay, so we split up the x term, grouped it and factored it, and then rewrite as the two binomials multiplied together. So we have 5x minus 3 times that x minus 2. Here was our x minus 2 in both cases. 5x came from here. Oops, I should do that in purple. 5x came from here. Minus 3 came from here. So that's just our factor by grouping. So this is the steps that's happening. Now I'm going to explain or show you why we use the minus 10 and the minus 3. So for our first example, we need to factor out 7x squared plus 29x plus 4. Now, remember, we want it to be in the form like an ax squared plus bx plus c. So this means our a is 7, it's this piece right here. Our b is 29, it's this piece here. And c is 4, this one from right here. So the first thing we do is say, what's a times c? So that's like our AC product. A times C is going to be 7 times 4. Here's A, here's C. 7 times 4 is 28. So now that we know AC, we need to ask ourselves, what are the factors of 28? That's 1 and 28. So 1 times 28 is 28. 2 times 14 is 28. And 4 times 7 is 28. These are all of the factors. You don't always have to write out a list, but I'm going to write out a list on these ones just to kind of help keep us organized. Now we have to ask ourselves, which set of factors here would add up to 29, or this b value, 29? 4 and 7 would make 11, so that doesn't help us. 2 and 14 would make 16, so that doesn't help us. 1 and 28 makes 29, so those are the two factors we need. This 1 and 28. So those are the numbers we're going to use to split our two pieces up. This 29x became 1 from over here. This 1, whoop, maybe I'll just get rid of that. 1 from right here, and 28. 1x plus 28x is this 29x. So this is what we split the expression, or the trinomial, up into. Now it's 4 different terms. Now is when we group it. So we have 7x squared plus 1x, that's one group. 28x plus 4, that's our second group. Now we factor each group. What can we take out of these red ones? Well, we can take x out, and that would leave 7x plus 1. We just took the x out of each piece. Now we look at this piece, our blue one, and we say, what can we take out of each of those? Well, we can take 4 out, and that would leave 7x plus 1. Now we notice 7x plus 1 is this binomial. 7x plus 1 is this binomial. So it happens twice. So that's going to be our first factor, our first binomial. Now in one case, it's being multiplied by x. In one case, it's being multiplied by 4, or positive 4. So that's going to be our second binomial, the x and the positive 4. So these are our two factors. Now again, you can always double check this by foiling. 7x plus x is 7x squared. 7x times 4 plus 28x. 1 times x plus 1x. 1 times 4 plus 4. Combine the 28x and the 1x into 29x. And now it looks exactly like what we started with. So this whole piece is the same as this binomial times this binomial. So this is our factored form right here. This is what we were looking for. So let's try another example. We've got 5x squared plus 13x plus 6. Now again, we're always checking for greatest common factor first. We can't do a greatest common factor of any of these ones, so we just go right into our AC method, and we'd say that A is 5, B is 13, C is 6. So A times C means 5 times 6. 5 times 6 is 30. Factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. We need to find a pair of those that will add up to 13. 1 and 30 don't work. 2 and 15 don't work. 5 and 6 don't work, but 3 and 10 will work. Oops. Those are the ones we're going to use. 3 and 10. So we break, oops, get rid of that. We break it up into 5x squared plus 3x plus 10 plus 6. Because again, this piece here, the 3x plus 10x, would combine back to this 13x. Okay, so we're just splitting it up so that we can group them. So this is what it would be split up. Now we group them. 5x squared plus 3x is one group. 10x plus 6 is another group, and we're still adding those two pieces. Now we factor each one. What can we take out of 5x squared plus 3x? Well, we can take x out of it, and it would leave 5x plus 3. What can we take out of 10x plus 6? We can take 2 out of that, and it would leave 5x plus 3. Now again, we notice 5x plus 3 and 5x plus 3. These are the same factor, the same term, the same binomial. So those ones, that's right here. In one case, we're doing that times x. In one case, we're doing that times a positive 2. So our second factor, the other binomial, must be x plus 2. Now again, if we FOILed this all out, it would come right back to this 5x plus 13, or 5x squared plus 13x plus 6. So these two binomials, when they're multiplied together, this is the factored form. We call it a factored form because it's this times this that makes this. So factors are the things that are multiplied together to get back to the original. All right, for our next example, we're doing a ax squared minus a bx plus c. So in this case, we have a minus here, not a plus. So in this case, you're kind of thinking of your b as being a negative value because we have minus 17. So a is going to be 3 from right here, b is going to be negative 17, and c is going to be positive 20. So a times c means we're doing 3 times 20, which is 60. 60 has a lot of factors. It has 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Those are all the different pairs of factors for 60. Now, again, we need our factors to add up, or to multiply up to 60, but we need them to add together to make negative 17. Well, if these are all positive, there's no possible way that they can add to a negative number. But we can make all of these pairs negative, because a negative times a negative would be a positive. So in all of these cases then, like negative 1 times negative 60 is positive 60. Negative 3 times negative 20 would become positive 60. So now we have all of these negative factors. They would multiply to 60, and we need to find the ones that would add up then to make the negative 17. So we'll check all these. Negative 1 and 60 wouldn't add up. Negative 2 and 30 wouldn't add up. Negative 3 and negative 20 wouldn't add up. Negative 4 and 15 wouldn't add up. Negative 6 and negative 10 would be close, but those don't add up. The only ones that add up are negative 5 and negative 12. Those will add up to negative 17. So those are the ones we use when we break it apart. Oops, that didn't get broken apart. All right, there, we got it fixed. So it would become 3x squared minus 5x minus 12x plus 20. Again, because minus 5x minus 12x would combine to minus 17x. So that's why we break those up like that. Now is when we group them to get us ready for factoring. 3x squared minus 5x is one group. Adding on, I'm putting this negative with the 12x. So we're adding on negative 12x plus 20. So here are our two groups. In our first group, what can we take out? We can take out x, and it leaves 3x minus 5. In the second group, what can we take out? We can take out a 4, and it leaves negative 3x plus 5. The problem with that is this is positive 3x minus 5. This is negative 3x plus 5. So these signs are the opposite of these ones. So what we have to do to change that is instead of taking out positive 4, we'll take out a negative 4. Oops, and I want it in blue. And when we do that, this isn't a negative 3, it's a positive 3, because negative 4 times positive 3 is negative 12. Negative 4 times negative 5 would be positive 20. So now these two factors are the same. We have a 3x minus 5, 3x minus 5. So that's going to be our first binomial factor, 3x minus 5. What is it multiplied by each time? X and minus 4. So x minus 4. So this would be our two factored binomial pairs. This piece times this piece equals this piece. All right, we're down to our last couple examples. In this one, again, remember, always check for the greatest common factor first. So when we look at this, 6x squared plus 22x minus 8, that does actually have a greatest common factor, and that's 2. So we can take 2 out of each of those pieces. When we do that, 2 times what would make 6x squared? 3x squared. 2 times what piece would make 22x? Well, that'd be 11x. 2 times what would make minus 8? That would be minus 4. So it's 2 times all of this. That would be that. That means that this 2, the one that we have in orange here, this is already a factor, because it's 2 times all of this. So there are actually going to be 3 factors in this one, 2, and whatever the 2 binomials that come out of this are. So now that we have the greatest common factor taken out, now we do our AC method. In this case, A is 3, B is 11, C is negative 4. A times C then means 3 times negative 4, and that comes out to negative 12. Factors of negative 12? Well, because it is negative, one of these has to be negative and one of them has to be positive. We're not sure which one is which yet. But we know that it's going to be the numbers 1 and 12, 2 and 6, or 3 and 4. These are the only numbers that would multiply to make negative 12. Now, depending on which one is positive and negative, that kind of determines what all of these will add up to. So let's say if we were looking at these two down here, if we had negative 3 and a positive 4, well, that would make positive 1. If we had positive 3 and a negative 4, that'd make a negative 1, because these are only 1 apart from each other. 3 and 4 are only 1 apart. So those ones aren't going to work. That's not going to help us. 2 and 6 are only 4 apart, so either positive 4 or negative 4 when they add up, and that's not going to help us. 1 and 12 are 11 apart from each other, and that's what we were looking for, 11. Now, do we want positive 1 or do we want negative 1? Well, in this case, we want negative 1 and positive 12, because negative 1 plus positive 12 would be positive 11. So these are going to be our two factors. So we'll rewrite our trinomial then. Remember, we still have the 2 out front. So it's 2 times all of this. We rewrote it as 3x squared minus 1x. We did minus 1 because negative right here. 3x squared minus 1x plus 12x minus 4. So minus 1 and 12 are right here. Minus 1 and 12. And again, remember, minus 1x plus 12x, that would add up to this 11x. Get rid of those. So, like before, we group those so that they're ready for factoring. We still have the 2 as a factor on the outside. 3x squared minus 1x is a one group, and 12x minus 4x, that's another group. Now we factor them. 2 is still the factor on the outside. We took x out of both of these, so x is on the outside, and it makes 3x minus 1. We took 4 out of both of these, and it makes 3x minus 1. Now again, like before, 3x minus 1, 3x minus 1. That's going to be our first factor. We still have the 2 on the outside, but then 3x minus 1 is our first factor. In one case, it's being multiplied by x, one case being multiplied by positive 4 or plus 4. So it becomes x plus 4. So we have 2 on the outside is being multiplied by all of this, 3x minus 1 times x plus 4. And because it's just 3 different things being multiplied, we no longer need these extra parentheses or these brackets on the outside. We can just say it's 2 times this factor, 3x minus 1, times this factor, x plus 4. So these are our 3 factors in the factored form of this equation. And we'll call it quits there for our first video.